So hi, welcome to the last session on the Open Security Summit, December 2022. And we actually have a really amazing panel here where we're going to be talking about living off the land and fileless attacks and moving beyond known bad, where we have Celine, Greg, Abbas, Éireann, and me. And I'll actually pass to Celine to give an introduction, set the stage for what we're going to be talking about in the next hour.
Yeah, sure thing. Thanks, Dinis, and thanks for those that could make it live and watching the recording. So yeah, so just to kind of set the scene. So you may have heard these terms before. Sometimes we use the term lolbas or lolbins, or so basically living off the land binaries, or rather living off the land binaries and scripts, which I'll get into a bit in a second. Sometimes also what we call then fileless attacks, and the reason why is because rather than for example, traditional malware, which uses specific files or specific kind of things that can actually be detected and that have signatures that are known to be bad. So fileless attacks are basically these kind of living off the land binaries, which is compiled code, for an example. So it's as an example, it's an executable that runs. It's something that runs in memory. So basically, living off the land binaries and scripts then means it's when an attacker is using the existing ecosystem, and in that sense, then using the tools, the legitimate tools that already exist in your operating system, for an example. And so it's misusing any existing tools and executables that are already there as part of the system, and then sometimes then able to hide in memory as well as part of that. So meaning, they can open something up, a legitimate tool that an antivirus might not pick up, for an example, and then misuse it in the wrong way, or to open something else up, to invoke something, to run something, to push a script through. So the reason why we wanted to discuss this is because it's been sort of kind of like one of the hot topics in security the last couple of years, and it's because it can be easy to not get detected. Because we have to think about security and approach it kind of in a different way rather than traditional when it comes to threat endpoint security and just threats. Yeah, so looking at things like memory forensics is important, looking at indicators of attacks as they're happening rather than just indicators of compromise. But yeah, we'll get into the details in a bit. So I hope that made sense. And if anyone else wants to add anything, go ahead.
Thanks, Celine. It's a good intro. And thank you all for spending the time to listen to us waffle on about setting the world to rights. I think just to add to that, I think it's an interesting start to the topic. I think one of the things is that we're getting more and more powerful in our tool detections. So some of the EDRs now are really, being able to spot things before almost they're happening. And I think living off the land principles are definitely a adversary that will be able to utilize these tools quite quickly. We'll know them inside out, and I think detecting them is an interesting conversation around how you best do that, breaking up the attack chain, using stuff like MITRE to help visualize where you should be looking for these kind of use cases. So I think it's going to be an interesting topic. I think those that are on the call have got a wealth of experience, knowledge, and uniqueness to our sets of conversation. So hopefully it should be a fun call. So
should we do some introductions then?
Yeah, let's do. I thought I'd just quickly jump in there because I felt
Go ahead, Craig. Yeah.
Unfair for you to be here. So Craig Gilliver, I'm head of SecOps for Johnson Matthey. I look after the Security Operations Centre. I look after the security engineering team, the OT team, as well as sort of the IDAM and divestment. So I've got a global team that deal with all a variety of security, not just incidents, but also engineering principles. Who do you want to go next?
Éireann?
Sure. Yeah. I'm Éireann Leverett. I used to be on the red team when I was at IO Active. It's many years ago, as you can probably tell by the white hair. But so I used plenty of the tricks that we're talking about here particularly for privilege escalation. But sometimes once you've got something on a box, you need to make it executable, right? And using some of these techniques was pretty important. So I can talk a little bit about it from a red team perspective. Currently, I'm CEO of Contingency Risk, and I do a lot of quantitative stuff like in the background. So I've become like a data science nerd for security work. But that means I do a lot of work with blue teams. And so later on, I'll switch and put on the blue team hat and talk to you a bit about different things we can do from a blue team perspective. It's worth saying too that I'm the chair of the ransomware SIG, Special Interest Group, over at first.org, which is the international team of incident responders. So yeah, thanks for having me today.
Yeah, and I'm Celine Pypaert, so I'm a security technical specialist at Microsoft, and I've got experience more around technical pre-sales, like sales engineering as we call it, from a security perspective, especially around endpoint security. But then actually I started out in a purely technical role as well, so around security operations. So yeah, and that's me. And Abbas?
Yes, good evening. Thanks for the invite, for inviting me to this panel, Celine. My name is Abbas Haidar. I am the SecOps manager for WordFirst, and I am the CISO for Alipay UK. I come from a very technical background. I've been worked in IT for most of life before changing career to cybersecurity. Thank you.
I don't know, Dinis, if you want to go.
You are muted, Dinis.
Oh,
You are
sorry.
muted.
Yeah, I'm Dinis Cruz. I helped organize the summit. I'm the chief scientist of Glasswall, which is actually a company that makes files safe, which is interesting debate here. I'm also the CISO Éireann Leverett. I did consulting for IOActive many years ago,
Cool.
when they're still based in Seattle.
Yeah.
And then, I actually have quite a lot of experience in writing exploits and writing evasion and kind of living on the techniques. And I kind of have a deep understanding of, especially Windows low levels, and that kind of what makes all this stuff possible. And these days I've been geeking out a lot on Kubernetes and containers and cloud and stuff like that, where there's a whole layer of this that also applies. So first topic, what do you guys want to focus on first?
I guess just first of all, because I know Craig touched upon things have changed and EDR has gotten a lot more, a lot stronger in being able to detect these indicators of attacks and when these types of attacks are happening. But I guess just as a first thing, maybe Éireann, I don't know if maybe you can tell us more around patterns of detection, since you brought up detections as well around this. And
So we're gonna go straight blue team. I thought we'd start red team.
Oh, right, yeah, right, okay.
Let me riff off of Dinis, especially if you were at IOActive too. I was there 2012 to 2015 or 16, I think. Not that it matters to the audience, but the thing that's useful to talk about, maybe I'll hit the Linux, you can hit the Windows sort of angle. But you wanted, let's say you had access to a Linux shell and it was in a limited context, it was chrooted or whatever, and you needed to break out, then a lot of the techniques that we're talking about here today would be, part of that process, right? And using sudo, using cat, using, different piping technique to try and get access to a higher level of privilege, or be able to write a file at a higher level of privilege than you were currently able to, was essential, right? And then later, we saw these techniques kind of be expanded upon until we all discussed, here's a catalog of 10,000 different ways you can elevate privilege using GTFO bins, I think is the Linux version. So if you're not familiar with it and you're on the red team, get out there and read it. And then I guess the equivalent is vol bins, vol bas. What is it in Windows? I'm not as much into Windows exploitation. I'll pass over.
I remember doing. Oh, sorry, go on.
Oh no, go ahead, Denise. Go ahead.
I remember doing a whole bunch of crazy stuff with. I don't know if you remember Windows shatter attacks, where you exploit the messaging system.
Oh yeah.
And in a way, I think the interesting problem sometimes here is that there is so many assets in userland, right? And we still don't have good, isolation. In a weird way, I always felt that the biggest advantage we had of containers was actually that finally we got a decent level of isolation. in whatever things runs. And yes, you might then have other exploits that might allow you to jump out, and maybe your containers are not fully well configured. But when you compare the previous world, where most things were not very well isolated, even within, even in web services, or especially in desktops or other environments, right? Where, the accounts, there was no way to isolate stuff within accounts, right? Which was actually a design principle, right? If you think about it, like Linux and Windows were designed, the idea that you have access to everything that runs in every process. And I remember when the first kind of exploits, of especially that the sort of fileless start to appear, it was basically that, right? You just start to loop around and you start to find other processes that you already have access to that maybe have more privileges or already do stuff for you, right? I remember the one of the really cool ones was you go, oh, we whitelist internet to go to the Internet Explorer, right? Or Firefox to go to the internet, and everything else can't go. And you go, sure, that doesn't make a difference, because all that process needs to do is jump into the Internet Explorer process and then use that to proxy request out. Right? Like,
absolutely. And we've kind of hit this from like the exploitation point of view, which I think is important and obvious, but then post exploitation is really important as well. And like when you're doing red team stuff, you don't necessarily think about it. But I guess in Linux, one of the things I tried to encourage anyone on my red teams to do was, before you run any commands in a shell that you've gotten access to, pull the shell history, because it might have like host names or occasionally even private keys, SSH keys or something, where somebody's been doing something. And so like pull the shell history, and A, you get a sense of like what kind of machine this is and what people are using it for. But B, you might get some secrets that help you pivot through the rest of the network. And so post exploitation almost by definition has to happen with these very same on the land techniques, right?
Yeah, it's true. It's a bit like for example, when it comes to Windows as well, it's interesting because some of the fileless threats or fileless attacks, sometimes there's either no file involved at all, or sometimes there's a file activity sort of indirectly. So as in there's no file present, but then you still have to use something existing.
Right. And I always find this naming convention is like a little tricky, especially with Linux, like memory is a file in Linux, right?
Everything is a file,
but I understand the point that we're making. It's not so much that it's a file, it's that, you can't just identify this with a hash and say this is known bad, because people are using like legitimate tools on the box. And if you were to blacklist the hash of, say, sudo or cat, or even less, then you're gonna run into real problems. And going back to that post exploitation thing, a lot of attackers would set up a remote shell to call out like every 6 months using a cron job. I can't blacklist the cron job, right? And maybe that's the starting point that we want to launch into some of our other discussion from.
Yeah, exactly. That's also an issue where you can't just block something that you actually need. You can't just, like you said, like blacklist something that you actually need.
I think that's when it comes down to, and I'm still not a true believer of behavior analytics being the answer, but I think UBA and the understanding of the behavior of the user to the interaction to the asset, if we call it the asset, because I think quite often from sort of a purple team perspective, and I see it from when the SOC deals with it. I also see it from when an attacker attempts it. It's sometimes very hard to determine exactly what is going on unless you're giving it time to evolve. If that makes sense, you almost have to play a little bit of that. This seems suspicious. Our gut tells us this is suspicious, but this is potentially still a user that could be just having a bad day, that is trying to do something that potentially they shouldn't be, and we need to let this play out a little bit longer. And I think that's where certain kind of techniques needs to be inframed on the individual that's monitoring that process, if that makes sense. I think understanding the attacker's perspective of what they're trying to do from a blue team. So I know that we're on a red team side at the moment, but I'm trying to bleed into the blue to come back to the red. But I think where I feel here is that we quite often can be quite jumpy and go, right, quick, let's go and get that alert, because it's firing on a principle of it potentially could be malicious, but actually quite soon you can default that as it's benign, it's only a user misbehaving. Giving it time to breathe and understand what it's actually trying to do. When you talk about cron drops, like you can't just go and blacklist, and kill cron drops, because there's a purpose of why they're there. If they're being used maliciously or not maliciously, they've still got a purpose, and we've got to make sure that we don't just destroy them because we think it's all bad. So it's I think sometimes having it to be brave enough to allow the attack to unfold, to just understand, is this an attack that we need to be warranted in dealing with, or is this something that's just a misbehaved user that probably could deal with having some more cyber training?
And I think that's the key. Sorry, Vincent.
Oh no, I was just going to say, yeah, that's a good point, Craig, because you want to be able to correlate the different events happening and whether those different events happening in a chain, kind of tick boxes that then show, oh, altogether these things or this pattern indicates.
Visibility is key, right? And having that, I'm going to get all visualized now, and I suppose I'm not changing my background to some sort of flashing image, but holistically it's all around trying to understand the end-to-end process. So if someone is trying to go into a position of living off that land and looking at these principles, I think you have to start looking at, where are they going to go next? What are they going after? How can we predict that? How can we understand the lay of the land? And equally, from the SOC perspective, we almost try and have to look at this holistically, because if they have compromised that machine, and 9 times out of 10 we're living in a very disconnected world, and I say disconnected because that sounds a bit random, but our attack borders have changed dramatically over the last couple of years because of COVID. So we're now dealing with people at home, in Costa, in a more volatile environment, and I think quite often we have to go, what is going on in AD? What is happening at a proxy level? What is happening, at a binary level? Is there things changing that, they normally do change, but are they changing in a behavior that we should be expecting to see if someone like an ATP group was involved? And are they going after something particular? Sorry, I ranted on and ranted.
So Abbas, you wanna go?
Yeah, I just want to say, from the SecOps, if I put the SecOps hat, that's why it's really hard to detect such attacks, and that's why you need something. You can't rely on a traditional, let's say, detection tool, like you need something with like artificial intelligence and machine learning to be able to tell what's going on sometimes, because there are a lot of processes going on, there are a lot of calls being made, and you need something to have to be able to connect all the dots together and say, this is a pattern here and this might be an attack.
I think the key that what Craig was saying is I think it is the context of what's going on. So I always find that the idea that the attacker can hit once and that's it, right? Like it's wrong, right? I love the concept that a 0-day is not an invisibility cloak, right? So the point here is, even if you have the most advanced technique to hide yourself, fileless, living off the land, all that stuff, right? There's a moment where you're going to do something that is not normal, right? There's a moment where you're going to do stuff that will touch an asset, will do things that are not. So I actually am a massive fan of behavior. I'm a massive fan of, the more you understand what known good looks like, the more you can detect this. And the thing about this is that, remember that the only real asset that we have against the attackers is that we should know, and this is a big should, right? We should know what our world looks like, and they don't, right? Because by definition, until they own the whole freaking thing, right? Sometimes eventually know more than you, right? Which is another big problem. But in a normal world, you should know more about your environment than the attacker, which basically means that when the attacker starts to do something that, or the attacking code, right, whatever, the attacking entity, right, starts to do something that is not normal, you should start to get your signals coming through. Now, at that moment, again, going correct to your comment of sometimes we do need to let it play out. I do think we need to sometimes let it play out for 2 reasons. First of all, it could be a normal business activity change, right? It could be something that is actually doing a new behavior, or others, sometimes you want to know, right, what the attacker is doing, right? As long as it's at the place where you're comfortable letting the attacker there, right? Because remember that, sometimes, not knowing what attackers we have is even more scary, right? So if you have areas where it's kind of almost a honeypot, right? If some parts of the organization, are a bit weaker, but you have to have that because of business reasons or a risk accepted by the business, as long as you know which one is the attacker, you can start to zoom in and really be able to block it as soon as you're ready to block it. But if you don't know the business context, if you don't understand what's supposed to be happening when, then this is impossible to do.
I was gonna add about, so I mentioned about behavior, and I mentioned I'm not fully there yet with it. I think one of the things that we've tuned our minds to help us with is risk-based.
Yeah.
Which I suppose bleeds into a little bit of behavioral analytics. But I think you're right. Until such time they step across that border, that boundary of that machine hasn't communicated with that device before, or hasn't done in a period of time that it's acceptable, it's very hard to understand what is going on. And you're right, knowing your topology is important, because I think you've got to remember they're going to be almost effectively blind to where they've explored. Once they've explored that particular piece of time, they then need to understand what's around them to try and understand where they move laterally next, or how, or what they're going after. And it almost becomes a sort of a listening game to understand of the behavior of either that piece of software that's being used at a particular time, or the service that's being utilized or compromised.
Okay. And the scary thing is when you can't detect, right? So for me, what's really worrying is when stuff happens and you're not able to correctly predict or connect, even reverse engineer what just has happened, what was done. Because a lot of these patterns, they're very weird, right? Like if you look for some of these attacks, jumping from one process to another, although there's some products to even do that a little bit. These days, they do it less, but it's a weird thing, to have a program that starts to use other tools that exist on the system. Those are weird patterns, right? Now, sometimes that might happen, but, if we cannot detect the benign cases, right, we will not be able to detect the malicious cases. And the coolest thing of this is that, and so what I found is that there's a moment where what you do pick up is lots of bugs, right? There's a sweet spot that the weird stuff that happens is either malicious, power users, or bugs, right, that exist in the system. And in a way, all of them, there's a lot of business value in us being able to identify it.
Yeah, that's a good point, Dinis. And there's also that insider risk aspect as well of not just risk, but, which most of it is unintentional, but there's also the risk of, what if an identity has been compromised, or what if, I think previously Éireann was mentioning privilege escalation and things like that as well. And just an identity that's been compromised, and how do you then have the detections in place and look at the different domains and look at it from across the chain.
Absolutely, right? If you look at an identity compromise, the patterns that they will have will be completely weird, right? You start to have impossible journeys. You start to have things accessed that don't make sense, right? And that's where you want to flag out, right? That's why, again, machine learning and being able to correlate that. But a lot of it is that we need to make our machine learning more clever, right? We can't just send piles of stuff into it and then hope it will make sense, right? We almost need to start helping it to understand what does good look like in our environment, especially when you have environments that still not are able to protect themselves. Like, for example, like most Kubernetes deployments don't protect the traffic internally, right? Which is still crazy, but a lot of them still don't, right?
Yeah.
And even the ones who do, there's blind spots, right? So you need to understand that, right? So you start to understand, is this a bug, or why the hell is this service now talking to that service, right?
I mean, you need to know what are the indicators of attacks. So that's what is it called? The product we use, that glass one, CrowdStrike Falcon. That's what it does. So it has, like, as an example, it does a lot of machine learning and stuff like that. And this is the normal behavior. And then it has indicator of attacks, and it takes it, you train it, you put it on in analytic mode for a long time. So it detects a normal user behavior. And then it will tell you what it is, an indicator of attack. So which is a series of things that an end user can use to launch a successful attack.
I think what's interesting about that is I'm not going to mention vendors because I think it's unfair on them, but I've seen too many.
I'll stop doing this.
Too many vendors fall foul
Yeah,
to
vendor neutrality. No, okay.
Yeah. We need a forward-looking statement. Please buy everything we say. I mean, I think I've seen too many vendors fall foul to monitoring an estate over a period of time and then trying to deem and classify breach through living off the land principles. And the noise has been so misinterpreted that actually they've then said, no, it's fine, you're not breached, it's all good. And then actually when they evaluate it with sort of the human eyes and a brain of interest, you suddenly go, hang on a minute, you are compromised.
Yeah.
You didn't understand the noise at the time, you didn't understand your estate, and actually the behavioral analytics of the device or the service is actually overshadowed your compromise because it's seen that as a normal behavior. And I think that's why living off the land or using native binaries is a really interesting technique, because I struggle today to see how you can classify human behavior as all being the same principles of attack, because you can't, because every human will work with it differently. You can show patterns of
but there's patterns, man, and this is the interesting thing, right? At volume, see, the interesting thing here is that it's very hard. It's very easy to create a pattern that looks like a human, right? A little bit, right? It's very hard to do that at scale, right? And it's very hard to do that in a way that you're not creating a pattern in itself. So, for example, too much randomized behavior is actually a pattern. In fact, I would actually say that the red team keys are the key, because the red teams are the ones that should be testing these all the time. So I actually think that our job from a defense point of view is to make, our job in the offense team miserable, right? Like in fact, they should have findings, which is to find the blind spots, right? In a way, the way I like to think about this is the red team should be doing something, and the blue team should be telling them what is. In fact, the incident response team should be telling them what did this do. Right. Well, in a way, I used to have a party trick on my pen test reports, because I say, hey, I'm going to add another finding here if you cannot tell me what is in there. Because if you cannot tell me what's on this pen test report, which I made no efforts to hide what I was doing, you have a much bigger problem because, you should know what it is. And I did have once an experience where the team was fixing the stuff as we found them, which was an insane experience. Right, literally, we could tell, and I never took screenshots so fast after that because we were losing evidence. Sometimes you just say, I'll go back and document that. I remember going back like 2 hours later, going, whoa, I'm going crazy. This was actually, so they almost were very cleverly using the signals of, in a way, a pen test, security exploitation, as where to go and fix things, right? So I always find that if you look at your, pen testing or your noise of exploitation, your noise on your websites and stuff like that, we should be making their lives or that life, or our lives when you're on that side, miserable, because every time you pick a signal of something that is malicious, you should be blocking it. So you should be forcing your attackers to work harder and harder, and you should be able to then eventually turn up the volume to weaker and weaker weakness signals, because you get rid of the main stuff. And in a way, you almost make it hostile for people to do crazy stuff, right? So when we talk about living off the land, I would argue, why should my normal business applications have access to that land? It's like, what's the business justification for that stuff to be there, right? So we should be looking at removing stuff, right? Or detecting things and say, hey, nobody uses those things, right? Yeah. Or if they use it, I want a signal.
Yeah. And I think that's a really important point. We've been discussing behavioral analytics and machine learning, and there's just this huge volume of data there that you have to sift through for the signal in that haystack. And that's why we have to buy these expensive products. But there are some simpler ways to do this, like in the olden days, they used to call it shaping the enemy, like forcing the enemy to attack you.
Yeah.
in ways that you have more control over. And I think that's what we forget when we're talking about living off the land. Like, I don't know how many people here are fans of canary tokens. I am. They're a cheaper product. They're really flexible. You can use them in amazing ways. I remember foiling a few pen testers and a few legitimate attackers through embedding them in various tools, right? Like, no one uses Python in this environment. Let's throw it in there. Curl, only an attacker would like curl their favorite tool set down to this box.
Exactly.
Like, this is, this is never going to be used for outgoing internet. It's just there to receive stuff. I'm going to make sure that if you're going to run any command on any of the machines that I'm in charge of, that I haven't had a chance of detecting it, right? Zipping up files and sending them away. This is like something only, data breach and ransomware actors like to do. And if occasionally I catch an admin like zipping up files and backing them up, ace, I now detect all my backups in my environment and in my estate. It's pretty cool. So I'm a huge fan of, poisoning the land, shall we say, and embedding a lot of tokens into either DLLs, like DLLs you expect to get hijacked, base crypt, like, why are you encrypting large numbers of files on these machines? I want to know that pretty quickly in advance. So you can tune your environment through the use of these tools so that haystack is just like a little bit smaller, right?
Yeah.
Forcing them down to a particular path that you own. I think that's the important thing, is if you can find ways to trip them into a position of control that's managed by yourself.
Yeah.
If you understand the terminology, that is a powerful thing. And canary
Absolutely.
tokens are breadcrumbs to that journey of ensuring that you can tempt them into a position of management.
Right.
And even works from a red team and a blue team's perspective, is both of them will benefit from that principle of understanding.
Absolutely. But look, half your state is a canary token, man.
Right.
Like basically, I would argue that every non-critical asset you can treat as canary tokens, right? Because you should be paying attention to what's happening to them, right? One of the really cool principles I like to think about, and I really got into this when I was looking at blocking traffic, is that we don't need to block the traffic on the first request, right? Even if you look at the path of a request coming in and out, right? You don't need to block it here or here or here or here or here or here. It sometimes is enough to detect it here, right? Because all we don't want is the thing to go through. And even if you did allow a request to go through, unless you really are looking at one exploit with one request with one stuff, which is completely off the charts, difficult and insane. It's like, really what happens in the real world, right? What you want is you want to detect that it's malicious. And the coolest thing is that once you have that pattern, what you also want to do is figure out where else that pattern was used. Like where, in a way, knowing that who the attacker is, or knowing what is the signal of an attacker, either from IP addresses or what techniques they're using and stuff like that, actually allows you to go back to your other logs. And I had some cases where we picked up a weird activity over here, but that gave us a signal to detect a whole rafter of other stuff, right? That was going on using the same threat agents or the same type of accounts, right? Like, for example, like the attacker uses one account to weaponize and exploit on a business application. The interesting question is, how many accounts do they already own, right? How many, what was the scale? Because a lot of this is about disrupting the business model of the attacker, right? A lot of this is about disrupting what they want to get out of this, right? So you don't have to catch on the way in. It's okay to catch on the way out. It's okay to catch it after a couple of requests, which goes back to the idea that sometimes you do need to let some of this traffic, because the noise that you get at the gate is too much. But the noise, as you look deeper inside the application, I found cases where you can discover business exploitation directly on the database and on a business logic, because you see crazy requests flying around. They're going, this is weird. Or like SQL errors are a great way to detect SQL injection, right? Because you suddenly see SQL errors on the database, like what the hell, right? And either they're mistakes or they're the first type of the attackers figuring out, right, what's going on. Celine, sorry, over to you.
I was going to say, just kind of because you're reminding me of this as well, and going back to canary tokens, it's kind of like using a canary token, making a honeypot, so to speak. It just kind of helps so that you can see how they have actually made their way in. So for an example, you know, if there was some code injection involved, you know, if something malicious was injected directly to the memory, or if a script was run somehow, it's just kind of to see, okay, what was their path in, what was the kind of vectors, the vector that they used, and the chain of events. And then that way, you know, kind of, it's almost like in reverse engineering, working your way backwards. So you see what's happened, and then you realize, okay, based on that, we know this is how this chain of events happened. Now, what can we do to not only have that visibility, what can we do to maybe prevent that from happening again, I guess.
And so, Sabah, just before you go, and remember that one of the most important questions that the business will ask us is, what's the impact, right? What happened, right? And there's a big difference between saying we got compromised here, and they had access to X, Y, Z of assets, but they actually didn't do anything, or they did a bit, or the worst one is we just don't know, right? We have no visibility, we have no understanding. You know, they, at that moment in time, they could have accessed half our database, right? That's the scary part, right? So if you can use that reverse engineering to figure out what has happened, not only that gives you visibility of what's going on, allows you to answer that, you know, is this a P0? Is this a P1? Is this a P2? Is this something that, you know, is problematic, but not as critical, which goes back to that point of, if the defense team and the incident response team and the SOC team cannot tell to the T exactly what the red team or the bug bounty team or your normal noise of attacks are doing, for me, that's a much more worrying thing. Because when we get to the real attack, you're going to ask the same questions and you're going to be like, you know, trying to figure it out, right? Abbas.
Yeah, thank you, Dinis. I just want to ask you guys, I never used Canary tokens. So why would you use a Canary token, not use a SIM? I mean,
Cost.
it's
cheaper. It's more flexible. I don't need 20 people. Well, okay, not 20. I'm exaggerating, but you know, a small team can manage a well-structured deployment of Canary tokens. And you know, I'm not saying that I would never use any other tools. I'm just saying, for a lot of people, it's a lot cheaper, right? And they're more flexible. And because I'm placing them where I want, and let's kind of pivot off of Celine a little bit too. You know, a honeypot, when we think of it, we tend to think of deploying an entire operating system somewhere to see what attackers do. But the idea is more flexible than that. It doesn't have to be a whole operating system. It can be a single file, right? Like I can make a file on my desktop that says passwords. And when that file is moved, everyone I know knows that I would never put my passwords in a text file. And then when it alerts, everyone's like, hey, who is this? What's going on, right? So it can be files, it can be processes, it can be network traffic signatures. You can embed something in a file that will become part of a network traffic signature, right? So what I'm trying to capture here is not so much like use this product or use this tool. In fact, there's many different people who make Canary tokens. My favorite is Think. Maybe somebody else likes, you know, Red Canaries, whatever. I'm not worried about that. What I'm worried about is how can we flexibly embed things in our own environment so that when something does go wrong, we're more confident that it's malicious and not accidental noise, right?
Yeah.
So there are an extra control, right? So it's not, they're not the, you can't depend on Canary tokens as the only control.
You can't depend on any control, right?
Yeah, I know, but how do they scale? And if you have multiple, like, let's say you have multiple attack surfaces.
Let me give you an example, right? Like there's a binary that was used in an environment that I was at for making backups. And you can embed this token in the EXE, and then you can ship the EXE to 10,000 endpoints. And then every time anyone runs this, I'm aware that they've made a backup. But if an attacker runs this because they're trying to get at the backups, as ransomware operators do, I also get them alerts, right? And so now you can go back to exactly what you were doing before with behavior analytics. But the point is, if you have a golden image of anything in your environment, that is a unique opportunity to embed the tokens in. And then different tokens can have different warnings, shall we say. So like, you know, I can have one that's specific to my executives' laptops, or I can have one that's specific to my IT support team's email accounts. And so the alerts give me a sense of exactly what's happening where, if I'm clever about how I've made those alerts, right? So it scales as much as you can copy files is the answer. And manage alerts, right?
And I think they're cheap as well, right? That's what's the amazing thing about it, is they are so cheap and they're so easy to hide in plain sight, that's I think is a powerful tool, because they can be an operating system or they can be a single binary. It doesn't matter, as long as you're putting in a position where they're eligible to be picked up through behavior that is malicious. I think they're a really powerful thing. We use them. I even use them at home, right? You know,
Yeah, you can make your own. You can
so
invent the concept yourself.
Yeah.
The point is that you know some things in your environment that shouldn't be touched,
Yeah.
right?
Yeah.
You know, like you can put using a real world metaphor just to drive the point home. Like if you don't have kids in the house and no one's going to steal cookies from the cookie jar, you can put poison cookies in the cookie jar. And then when there's some, dead person lying there, you're like, well, everyone here knows not to eat the cookies, right? My point is we have to be better adversaries to our adversaries. And if you're going to run a random executable or a random file in my estate, you got what's coming to you.
So you suffer the consequences. I mean, not probably one for today, but is it fair to ransomware the ransomwares?
Well, I wouldn't say ransomware, but give weaponized stuff, right? I remember once we modified a web app that when it was being attacked, we started to send crazy requests back, slow requests, large requests, like really, like game up the answer, right? And also the other that was really cool was to start to give non-deterministic login information. So for example, for these guys that were trying to brute force stuff, we're able to, once we detect brute force, we will start again, deliver non-deterministic results, passwords that would then we say they're valid, of course they're not valid, accounts that were not supposed to exist. So what we were doing, we were corrupting the data set. So suddenly the data set became way less valuable because you had so much more noise in there, right? But I really like
create
stuff,
right?
Right?
User accounts that don't really exist, that anyone who's trying to exploit, it's a warning,
Exactly.
like domain admins that don't really exist. If you're trying to take over Active Directory, like I have some sense of what's going on. It's a powerful and flexible
but that goes down to the idea of creating data points that you understand your network, right? Like and even like we talk about living off the land. Well, like you said, the land does not need to be benign, right? Like
it can be
some of
hostile.
those things should not work. Like you say, well, if you're going to use double get, why is it double get not actually telling you an alert, right? And I actually saw this work also really nicely in the early days of CSP, the content security policy, right? Where there was this really interesting analysis that basically looked at, and I think at the time was Firefox was one of the first ones that actually had it. But because of the alerting of the content security policies that you can, you get an alert back when something happens. So there was a team who actually was able to pick up exploitation of cross-site scripting in their environment and attacks, because although only a small population was impacting, it was statistically significant for you to go, whoa, what the hell has just happened here, right? And then it was that alert that, in a way that was for me an interesting wake-up call to say, look, sometimes you don't even need more than 5 or 6 or 7% coverage, right? That will be enough for you to get a signal to tell you, well, something is really weird going on here.
I wonder if maybe we should leave a little space for questions too, right? I don't know. Like, I'm enjoying this. I'm sure we could all keep talking, but
yeah.
That's
I'll
the
keep an eye
danger.
on the questions. I think there's a comment from Peter. Yeah, forward-looking statement: do not poison cookies in your workspace kitchenette.
I'm not trying to throw a blanket on the fun, guys.
I apologize for making that metaphor, especially as a person with toddlers in the house. It's like it's not funny, it's not clever, but I needed a metaphor to say that you can sort of poison the landscape of executables and commands in your environment, so that an attacker can be detected, right, rather than necessarily prevented.
And Éireann, you gave ideas on fake user accounts, fake admins accounts. You guys are all security experts. I am not. I'm a VP of IT, so I'm adjacent to what you're talking about. I understand 50% of the technical terms, and I get the gist. What I liked about your suggestion about fake user accounts, fake admin accounts, I'm trying to think what's the best way for me to surreptitiously maybe work with my security team and suggest that and see how long it takes us to catch it. I mean, this is, I've never thought this way. So this is great. Thanks, guys.
Yeah, I mean,
It's useful. Let me pivot off that in two ways quickly, and then I'll pass to you, Craig. Like,
Yeah.
one, a lot of attackers, when they're trying to do something, they need to get an account to get started. And so like even the process of creating like 20 accounts in rapid succession is a thing that an attacker might do in certain circumstances. And so like you having some conversations with your security team about that is no bad thing. And then secondly, you know, you control user accounts. And so if you have a few of them that you know deliberately aren't supposed to be doing anything, and then you detect activity there, that's really useful. I'll give one more example from another computer emergency response team that I know to hammer the point home before I pass it to Craig. And that they were working at a bank, and obviously people break into banks to try and steal money. And so they were blocking people from taking money and transferring money as the CERT team should. And then a new CERT team, you know, leader came in and said, wait a minute, what I want you to do is allow them to put the amount of money in that they're trying to steal before you block the transfer of the funds. And everyone's like, why? Like, you're essentially creating a phishing page where they get to put in an amount of money. But they did it. And in the next quarterly report, they were able to go back to the management and say, we prevented this much money from being stolen from your bank. And we would like to double the budget for our security team. Et voila, right? So
it's almost like you read my mind, my friend, because I was building up to the fact that I think sometimes delivering these areas where you can siphon information around what's going on in your estate, with like fake accounts is a great example of where you set the perimeter and the values of what that account does. So if it starts to behave in different ways, you're alerted sooner. But equally, you give the opportunity to and I hope your cyber team, you know, or your CERT or wherever your SOC is that, you know, it's not a dark art. You've got to start thinking around, if you as an attacker, how would you compromise your own estate? Because the more you think about how would you compromise your own estate, will give you the ammunition and the techniques to how you can defend from your estate. You know, red team, blue team, you merge that together, you become a purple team, and that's really important. It's important to test your own controls on the principle of how you want to try and get around them, because that's how you have hardened defenses. And accounts, you know, honeypots, canary tokens, you know, specially placed, you know, deal files. All of these are a really easy technique that, coupled together, become a very powerful story towards your board when you want to try and say, well, look, you know, these guys are actually protecting us, and we're finding X, Y, and Z, and this is why we need this extra bit of cash, especially for the Christmas party.
Yeah, exactly. And Craig, I think that's also part of knowing your infrastructure. It's knowing how to break into it. It's knowing how to compromise. Yeah, and that's something that me and even some of my colleagues will tell to each other, especially those of us from a security operations background or pen testing, you know, pen testing background and such. We tell each other, never forget to think like an adversary. You know, never forget to think like a hacker. Which, you know, just sounds very, you know, could sound cynical or maybe a bit nefarious for some, but it's just, I mean, you have to. You know, it's the nature of the job. I mean, it's a bit like, you know, if I were. I mean, I'm not going to get into the whole, you know, it's different if you're a developer, but if, for example, because of my security background, if I were, you know, if I developed an app, and sometimes I do in my spare time, but if I do that, then I just start to think, what would I do to break it? How can I break it? And then how can I break into it? You know, where are the vulnerabilities or the weaknesses? And then what are the ways in? And then therefore, what do we need to do to protect, you know, or at least be able to detect and then respond? And I guess in terms of like prevention, because prevention is quite difficult as well to think about around this. And you know, going back to like principles like least privilege, then that's kind of important when it comes to kind of reducing the attack surface in a way where if you don't have too many permissions, too many elevated permissions, unnecessary permissions, then it just makes it that much, I guess, that much easier, that much harder for that kind of privilege escalation, or, you know, that kind of pivoting and such.
Absolutely, right. The more you can control your privilege, the more, again, you detect the escalation, right? The use of privilege they're not supposed to have, right? So one of the comments I just wanted to make is on the visibility thing, is that one of the reasons I think it's so important to dig deep on P2s and really try to reverse engineer what's happening is because in most organizations, right, there's a moment where you can say, we don't have insider threats, right? Or we don't have known insider threats. Because I would argue, if you know, they shouldn't be there, right? So if you know who the insider threats are, you should be removing them. So there's a moment where you go, I don't know, I don't have insider threats. And there's a moment where, depending on, I guess, your security budget, your security posture, you have to go to the business and say, hey, we're not able today, or we're not designed to prevent against this type of insider threats, right? Let's say, for example, developers having quite a lot of privileged access to SIM access, right? But you should be double checking that. And the idea of, again, a lot of the insider threats, they won't do one exploit and go over, right? They will do small things. They will try things. They will figure out what we can do. So as you zoom in on your analysis, what you also are validating is your assumption. Do we have insider threats? Because if you do, you start to see certain activities. You start to see certain things that, wouldn't be normal. And then that's a great example of then going to the business. And I really like that example of doing the budget, right? Because then you say, hey, we now starting to have this kind of activity or fraud or malicious or dangerous, or we have a new compliance requirement that we need to fulfill, or our threat landscape has changed. We need to improve our security here, here, and here. But then you are evidence-based, right? And again, your incidents should give you that evidence. Because again, you're not going to go from 0 to 100, even on your attackers, right? There's going to be an escalation. Cool.
I was leaving some space there for Abbas. Final word.
Yeah.
I just wanted to re-emphasize of what Dinis was saying earlier as well. In that ability to isolate your attacks, it is something very important, and which I really like, in the new containerized like quad, like Kubernetes and stuff like that. And things there will only go wrong if you misconfigure them. You can control your pods, you can control your attacks, and this is something, I think this is the future here. This is where you can isolate your attacks better. So if you can isolate your attack, stop it from spreading, it does not matter how big it is. So if you can stop it, that will be really good.
Yeah, definitely. And does anyone have any, just conscious that we've got a couple minutes left, does anyone have any tips or kind of advice or things that you've kind of learned in terms of detection and prevention and sort of response kind of aspects, or just anything that you've seen aside from like behavioral analytics and using XDR and SIEM, again, for those who are able or have that.
I've got a parting comment that I always tell my guys, because I think sometimes what can happen is, from a defender's perspective, that the SOC analyst can be a bit nervous to ask questions because they're scared to, unless they've got all the facts and figures in front of them when it comes to a fileless attack, they're almost reporting against their own tools, right? So they're nervous to go, hang on a minute, this feels wrong, and speak to the user around what the behavior is looking like. So I've always said to them, don't be scared to ask. The worst they're going to say to you is no. So don't be fearful in the response, because you never know what that response will look like. So I think it's important just to make sure that you're transparent and you're asking these questions to the end user. Did you run RDP? And if you did, why did you do it? Because from our perspective, we're looking like it's malicious. And I think it's important just to have that behavior, because this is not a dark arts, right? This is just us that are very broad skilled across a lot of sectors, and we can develop the understanding of how this works. And I think speaking to the end user, just being open with them, sometimes the response is going to be quite good back, and that will give you some more knowledge.
I just want to, this is very simple, and I agree with you, Craig. I'm just going to give you a quick example of a real-time scenario. We used to have a secretary, one of the companies I used to work for in London, and she was like scared. I'm not saying scared, it's just like she was not clever enough probably, or confident enough to call her boss and say, shall I transfer this money or not? She received a spoofing email. They ended up losing £75,000. Well, I know the bank returned the money and all of this, but sometimes it's a matter of a question, probably picking up the phone, calling someone, say, did you ask me to do this? Did you mean to send me this? So it is as simple as that. And in terms of prevention, When you run thing in analysis mode, you run it there for a reason. You need data. We always need data, and it's never, in my understanding, it's never enough. So you need a lot of data to be able to, to set up like your behavioral, to detect behavior. Like when Dinis was talking about patterns, you need a lot of data here, and for you to be able to, not us as a human being directly, we can't do this, but I mean for a machine learning or AI client to be able to detect a abnormal behavior, it's going to take it time. When you need data, you always need data. Sometimes I know some companies, they used to run we were talking about an APS, they did run it for 6 months and they still had a breach, like small breach later on. But I mean, like, yeah, you run it for a long time, so you need the data. Data here is always important. Wherever you are, you need the data. Thank you.
Yeah, definitely. You need the data, and then you need to be able to make sense of it as well. Going back to what Denise said about sometimes we can drown in too much data, and then how do you know to make sense of it and get that intelligence, and also how do you know that it's accurate, that it's actually telling you something, and that it's malignant instead of benign.
Exactly. Well, that's why, look, my final thought for the day, right? Is I think use your red team, right? Use your existing attackers that are already probing your system, even your users, right? To basically allow you to ask really good questions on your detections, so then you get visibility into that world. And on that, everybody, thanks a lot. This was a great session, right? We need to do more like this, right? I think this is a great panel.
Oh, is it over? Wow, that was so quick.
Yeah, it was quick.
Sorry, I thought you were going to say something, Craig. I'm not sure.
No. I was just going to say it was good, right? It flies by when you've got like-minded people talking about the topic that we all love. So I think it's something that when you've got a room full of people that just enjoy this whole concept, it's fun to do. But it flies by.
Yeah.
But we've got to be disciplined, right? Because I need the dinner. So,
yeah.
And I'm going to play football.
Talks.
So, all right, guys, brilliant.
Thanks
And
all.
I'll see you in the next
Thank you
summer.
very much. Thank you.
cheers,
Thank
then.
you, hackers.
Thank
Well
you,
done,
guys.